All right, we've had some guys want to know about shocks, so I'm going to explain a little bit about shocks. I'm no guru. We just do it ourselves because I do know how to do it a little bit and can't afford to pay somebody big money to do it. So we're going to show you how to at least take a shock apart, put it back together, kind of what you do, what we're looking for a little bit. So let's get into it. I've already checked the gas pressure, but the first thing you want to do is check the gas pressure and make sure it's right. With these shocks, you can take them apart with the gas pressure in them. They won't explode on you. If it's not a canister shock, base valve deal, you have to degas it first or you'll make a mess. And it's not fun. So you put your cup on to catch oil. Back all your rebound out. Make sure your work area is pretty clean. Ours is not as clean as it needs to be, but it's clean enough to get the job done. Break your closure nut loose. Take the nut off your piston rod. And lay everything out the way it comes off the shock. All right, this one has too much compression, so we're going to take some away. You measure your shims. Right, the further you go out the stack, the more high speed you get. It affects the whole graph, but a thicker shim for the force shim will affect high speed, which is where we really want to change this thing. So this one is a 12 thousandths, where the rest are 6 thousandths. All right, we bought these shocks used. It had 3 constants on it, which is the very last shim, goes right below the nut, which will affect high speed too. So I'm only going to put 1 constant back on it. Then you just stack your shims back on in the order they came off. All right, while you got the shock apart, you want to check everything, make sure it's in good working order. Check your piston band, make sure it's in good shape. This shock I already know, I've checked it out, I know it's good shape. But you pull your piston band off, check your O-ring, check all your shims, make sure they're in good shape. Your O-ring on your closure nut, make sure your jet's tight, make sure it's the right jet, the one that you want. There's open, there's what they call split valve, bull nose, whatever. So just rebound jet, just figure out what jet you want, and that's based on driver, shock builder, whatever. We run an open jet, so our stuff's pretty simple. All right, with your piston, you got to decide how you want it in there. This particular piston is a 1 degree linear digressive. If it's linear, it doesn't matter, you just put it on there. Linear digressive, if you want the linear side on the rebound, you put it on this way. If you want it on the compression, you put it on this way. In our case, with bump stops, we're linear compression, digressive rebound. Put your piston on, stack your shims back on the way they come off. These shims are to take up the distance between the valve face and the piston face. You got 65 thousandths, I believe, between this point and the bottom of the piston, so that's preload. And you measure your shims and figure out what preload you want. That's going to help determine your rebound and your 0 point. So stack your shims back on. And put your nut back. Torque it back down. You have to know the spec on the shop. Penske torques to 25 pounds. And then you have to replace the oil that you've lost, and to keep air out of the shop. Fill it up to about 3/4 of an inch from the top of the shop. All right, once you got your shop filled up, say have your closure nut all the way down, ease it into the shop, push it down, a little bit of oil will squirt out. I filter my oil to use on R&D stuff. I don't run it in race shocks, but shock oil is expensive to just sit there and play with, so I filter it out, R&D, and once I get what I want, then I build it back with the good quality oil. All right, once you get it put back together, close your rebound back off. And then you adjust it to wherever you want it. This is a left front shock, so it's closed off. Then you go to the dyno. All right, once you get it on the dyno, you got your program pulled up. You're gonna run a test. All right, you're gonna run a test. So you click to pull up your test. Zero your load cell. Start your test, it'll pull up a menu for the shop. And then you can fill from file. And then you can go in here and put in all your shim sizes if you know them, which you should because you built it. I don't have them in there right now, but I'll put them in there at a later date. Do your compression setting and your rebound setting, and in the notes I always put how much gas pressure is in. And then you hit OK. It'll tell you the dyno's about to start. You hit OK, the dyno will run to a set warm-up on the shop, and then it'll run the test. In our case, we run 3 different tests. Now, once it runs on the dyno, it'll pull up a graph or a page where you can name the shop, so you can keep up with it. You can name it, you can put a serial number on it, however you want to do it. Since I'm just checking right now, I'm just going to go with what it pulls up, which is shock data and a number, and then it'll pull up the graph. Once you pull up the graph, you can see the blue line is what the shock was, the pink line is what the shock is now, which we took out at 10 inches a second. It was 146 pounds, 147 pounds. It's now 132. We compare that to the shock that we've been running, and it's close enough. I think that we can work with it. It's 12 pounds difference. 11, 12 pound difference. And that's close enough. All right, you got to decide how much compression you want, how much rebound you want, how much control you want with that rebound, which is, in the way I do it, driver feel is 0 to 1.5 inches, 2 inches. So that's where I look at rebound the most. More linear the shock is, the more grip it'll have. But you can't have enough control and grip with the linear. So you sacrifice a little grip to keep it on the bump stops, because the bump stops make the grip. With a standard setup, you could run a linear shock and gain a little more grip that way. Bump stops take care of that, so you don't have to worry about you still have to worry about the grip in the shock, but it's not, you have to have the control to keep the car on the bump stops. All right, so now you know how to tear down a shock, check it, run it on the dyno, kind of what you're looking for. Shocks are not a fix-all. You can't make a bad handling car handle good with shocks. Shocks are a timing tool. They help your setup. They're an important part of your setup, but you can't fix everything with the shock. So you got to kind of know what you're looking for on the shock, what you're wanting it to do timing wise, when you're on the stop, how long you stay on the stop, does it ever come off the stop, that kind of deal. So hopefully this will help somebody along the way at least understand shocks a little bit better. If you're interested, we can do more. Like I said, I'm not a shock guru. We do it because I have to do it, monetarily wise. Hope you enjoyed the video. If nothing else, maybe it's a good laugh for somebody. Thanks for watching.